Hello everybody and welcome to Ask the CEO. Today I'd like to introduce a very special guest. He's the security marketing lead for Intel Data Center and AI Marketing Product Strategy. It is my pleasure to welcome Brian Richardson. Welcome, Brian.
Hey there. That title sounds a lot longer than I remembered it, but you expanded all the acronyms and we appreciate that.
So, Brian, Intel just launched its 4th generation Xeon Scalable processor, which is geared towards its enterprise customer base. And one of the topics on everybody's minds is security. As you know, data breaches are unfortunately a very common occurrence. And with that comes the risk of ransomware shutting down businesses and public services, and not to mention the damage done to its reputation, which is virtually incalculable. With that on our minds, what are some of the challenges enterprises face when it comes to securing their infrastructure?
Yeah, I think most enterprises are concerned about like 3 things. 1 is the increasing number of cyber attacks. 2 is increasing regulation. And the 3rd would be the increase in overall security spending. So if you look at different metrics on what people are calling a cybercrime economy now, Mainstream Technologies did a study back last year and estimated that the entire cybercrime economy is about $1.2 trillion. That's the trillion with a T, unfortunately. And attacks get more sophisticated. So most people try to take a software approach to stopping attacks or putting up a cybersecurity perimeter. And the problem is that the attacks are now so sophisticated, they're hard to stop with just software alone. So in 2019, Sophos did a study, reported that 75% of companies that had been attacked by ransomware were running some kind of data protection, and it was up to date. So now we're getting into the second factor, which is regulation. Because of all the different issues that we've had with data privacy and data protection, you're seeing a lot of new 4-letter words enter the vocabulary of CISOs, and not ones I'm going to say on this podcast, but things like GDPR, NIST, PIPL. There are new executive orders coming out every year. HIPAA regulations are still in place. And if you do payments, you have to worry about PCI requirements for payment processors. And now you're getting into just overall increased spending on cybersecurity. Since it's now a focal point, you're looking at last year's estimated worldwide spending in cybersecurity, according to Mainstream, was $133.8 billion. It's a large number. I had trouble comprehending it. So those are the kind of things that really every industry is facing. There's a big cybersecurity issue. There's a lot of focus on it from a spending and defense standpoint, but a lot of the traditional tactics of, just putting up malware detection or virus protection, most of the attacks are now really beyond that scope.
Sure. And as we evolve our technologies, the bad guys evolve their technologies as well. So what are some of the way enterprises go about solving these security challenges?
Yeah, since we've got a limited amount of time, I just want to focus on data center today. In data center, what the challenge is that you have people that are doing on-premises work and they're migrating things towards the cloud. And when you have both of those issues, whether you are the controller of the machine in its entirety in a standard, enterprise environment, or you're moving to a cloud service and you're relying on a third party to provide the hardware and the infrastructure, our customers are concerned about kind of 4 major areas, and we address all of those in our Xeon products. So you have platform integrity, safe software behavior, crypto acceleration, and confidential computing. So if you look at platform integrity, that's where people get into a lot of things like root of trust, which is an essential component of a zero trust strategy. So you're trying to confirm, is this platform the platform you expected? The way I like to think about root of trust is, if you've noticed from the background, I'm a little bit of a Star Wars fan. So if you look at something like an R2-D2, that is a perimeter defense issue, and you're not confirming root of trust of the droid that happens to hook itself up to the garbage compactors. If they had done a red team on the Death Star, they probably would have failed that security audit. And then you look at something like Rogue One, where you have K2SO. That's the big hulking robot that they stole from the Empire and reprogrammed. It was an Imperial asset, and then they got reprogrammed and they didn't re-verify it when it came back in, and that didn't turn out great. So verification of that platform at its barest level, whether it's firmware, hardware, basic configuration, is a big part of platform integrity. Safe software behavior is preventing common attacks. So if you look at stack behaviors, you're trying to prevent people from using stack manipulation to take known good software and basically ransom letter it together like an old magazine cutout into something malicious. Now, crypto acceleration is making sure that you can accelerate your infrastructure when you up your encryption strength, or up the basic power of the keys that you're issuing to your customers. We've all heard about the whole post-quantum problem, where quantum computers one day will probably be able to crack keys of things that are signed securely today. So upping that key strength is important, and you want to be able to have some kind of offload processor like Intel's QAT that allows you to take the increased burden of that off the host CPU. The fourth one, which is the one I really want to focus on, is confidential computing, because this is kind of a newer approach that we're taking at Intel and within the industry to protect data when it's in use, not just at rest or in transit. We're good at protecting data at rest with SSD encryption. We're really good at protecting in transit with HTTPS and other encryption protocols. But in use, typically you have to unencrypt the data. And that's an area that we want to focus on, because I think that kind of change in the way that we do data protection and use is going to unlock a whole new set of industries and a whole new set of business opportunities.
So, Brian, how does the fourth generation Intel scalable processor address the enterprise security needs?
Yeah. So if you look at something like confidential computing, we've had technology in play for a while called Intel SGX, or software guard extensions. And that is designed to protect data in use through the idea of a trusted enclave. Everything in confidential computing, runs off that backbone of, this is a hardware enforced area. We're using isolation to keep the data that's in process inside of that trusted execution environment. And that's done through hardware and software enforcement. So only authorized software has access to the data inside that trusted execution environment. With something like SGX, that trusted enclave happens at an application level. The newer technology we've included, the trust domain extensions, or Intel TDX, happens at a VM level. So it depends on kind of the sliding scale of how secure does your data need to be, what kind of regulations or constraints do you have. And a lot of the things that go into the hardware behind the 4th Gen Xeon are designed with these two kind of concepts in mind. Like, even though SGX has been around since 2015, we've managed to, enhance it up the level of isolation, and also work on a number of different software partner solutions and open source solutions like Grameen that make it easier for people to take advantage of that. And then everything else in the platform, from the platform integrity to safe software behavior, supports the overall safe operation of that platform. So it's really just taking the kind of concepts that we've had in play for, say, platform integrity. I used to work on firmware quite a lot. So things like Intel Boot Guard or platform firmware resiliency make sure that first code to run on the platform is, in the state you expect it to be. Establish that base root of trust so that everything else, the safe software behavior, the crypto acceleration with things like QAT and our other processor extensions, are there to support a known good platform that confidential computing can run on top of.
This sounds like a lot of great information. Can you share some case studies of it in action?
Yeah, the case studies that come to mind, we do a lot of things with confidential computing in areas where there's heavy regulation. So think about healthcare, financial services, government applications. So the two I want to focus on, one is in an automated driving scenario. So this is confidential AI, where you have an AI machine learning algorithm. You want to train it, but the data that you're working with has some personal identifiable information, or PII, in it. In the driving use cases, when you go out into a city street and decide that, okay, I need to capture, video, you're going to get people's faces, you're going to get mailboxes, you're going to get license plates. So you have to be able to separate that data and store it differently. So if you're working with a company like Bosch, all of that falls under GDPR in their automated driving training system. So they can't just blur it out, right? You can't blur out the number plates, because the AI that learns how to drive the car doesn't know what a license plate looks like, which could help them identify a vehicle. If you blur out faces, then I don't really have a smooth face anymore because of all that firmware I used to write. So I don't want people with, age lines like me to get run over in the street because it was only trained on, blurred out faces. So what Bosch does in their system is they separate it out like Photoshop layers, and they keep all the personally identifiable stuff in an SGX enclave. So that allows them to meet all of the regulatory compliance issues they have with GDPR, but at the same time meet all the automotive safety issues that they need to solve for that regulatory environment by making sure that that full data can be reassembled when they use it to train their customers' platforms. And the other is a medical use case with UC San Francisco. They wanted to do collaborative research between different health institutions. Now, the problem with that is that HIPAA regulations in the US make that extremely difficult to do. You can't just take multiple databases and kind of shove them together, because you end up then mixing data and potentially exposing a data set from one hospital to the other. So they partnered with Beekeeper AI to create a system that patient information is pooled, and then it's only combined inside of the Intel SGX enclave during the training process. So the data is anonymized on its way in, but the enclave keeps the data private from other parties and maintains that HIPAA compliance. So now they get the benefit of absorbing data from multiple institutions, but staying within the regulatory envelope. And that's the thing I think is most exciting about confidential computing in general, whether you're doing it with Intel SGX or Intel TDX, is you now have these opportunities when people move into cloud environments or want to share and collaborate on data. You're able to share that in a way that doesn't bring a privacy or regulatory risk into that environment.
Yeah, and especially in healthcare. So I know somebody that is working on a collaborative solution, and these are some of the challenges. Because if you think about it, the more we pool our data together, the better we all are as a society. So it's great to see that there are solutions that are coming out there that enables us to do collaborations like that.
Right. I mean, the lawyers want me to say no system is absolutely secure, but what we can do with technologies like confidential computing is make sure that we are reducing that overall risk and making sure that people don't skip a business opportunity because they fear that there's a regulatory issue or a privacy issue. Right. We want people to be able to take advantage of moving things to the cloud, scaling their stuff up, but we want them to do it in a way that provides the best constraints so that they can operate in those environments and not, not fear regulation, right? Not fear the concern of, what's going to happen to them if they move into a business model. Right now, they've got a framework that allows them to look at the data compliance, look at the regulatory environment, and say, yes, I still can scale this and take full advantage of the technology.
Yeah, I see this as a huge game changer industry. So, Brian, how can people connect with you to learn more about the 4th generation Xeon Scalable processor and also connect with you?
Well, connecting with me personally, I'm on LinkedIn and Twitter. Intel_Brian's my Twitter handle, and you can just look for Brian Richardson. I'm the one that works at Intel. If you want to actually talk to smarter people than me and learn about this technology, I recommend you go to intel.com/confidential computing, all one word, no spaces. And that's a good primer on the background behind confidential computing and the different technologies we offer to support that.
Great. And I'll post those links in the show notes so people can just click on it and get right to it.
All right. Appreciate that.
Brian, do you have any parting words of wisdom that you'd like to share with the audience?
Yeah, I think there's two things to think about. Right now, a lot of people are looking at transitioning from an on-prem model to a cloud or services model. A lot of it is that transformation from capital expenditure to operational expenditure. So if you see CapEx to OpEx in some, trend slide, that's what we're talking about. When you do that, evaluate your needs, whether it's data sensitivity regulations or compliance, and think about the hardware running on the service. A lot of things that when they get SaaSified, as I call it, they think the hardware disappears because they don't interact with it. Hardware is extremely relevant to software outcomes, whether it's acceleration or enforcement of security boundaries. And the second is, I hate to say this about my own job, but security is not sexy. It's infrastructure. We're talking about plumbing. and I do a lot of hobby work on my house and my barn. And I found out that plumbing is really important, especially if someone before you doesn't do it well and you have to go back and refactor everything. It's really messy. So think about stable foundations when you work on stuff. I know we're all going for the coolest trend and the kind of shiniest object on the roadmap, but don't forget the infrastructure that lies behind it, and make sure that you're building on something that is stable enough to scale to your needs and secured enough to meet your requirements.
Brian, thank you so much for sharing your time and your wisdom. I really enjoyed having you on the show.
Great. Appreciate the opportunity. Thanks a lot.